What if I told you that the cure for cancer is right at our fingertips? Or what about the ability to put an end to the spread of AIDS and HIV across the globe? How about the assurance of a world free of miscarriages? This sounds like a medical paradise, right? Now, what if I told you that in order to harness the technology that solves each of these problems, you would simultaneously be dooming the entire human race to a weapon far beyond our imaginations? Well, back in 2018, a Chinese scientist by the name of He Jiankui claimed to have altered the genomes of twin baby girls. Through a process called germline gene engineering, Jiankui deleted a region of DNA to prevent HIV in a way that would pass down this modification to future generations. This story seems to have a happy ending, yet the modification of germline genes provides a rather unhappy ending for humanity. Despite the immense possibilities that come with the practice of germline gene engineering, the outcomes would ultimately bring more dangers to society than benefits, while also breaking moral standards, thus justifying the ban of these procedures. Through teaching you this topic, I hope to persuade you against the use of germline gene engineering on humans. I'll begin by defining and explaining some common terms that surround the idea of editing genes, before diving into some of the safety and requirements of possibly implementing this procedure into common practice. I'll then point to why this is an important issue from both a moral and a societal standpoint. Finally, I'll explain and refute any objections to my arguments before describing what we are to do next regarding germline gene engineering. Now, this is a newer topic on the science scene and includes several technical terms that many of you may have never heard of before. In order to give a base understanding of my arguments, I will start with some definitions. At the core of this subject is the human genome and the DNA within the genome. The genome is an organism's complete set of genetic instructions. Each genome contains all of the information needed to build that organism and allow it to grow and develop. The genome contains our DNA, or the long molecule that contains our unique genetic code. It holds all the instructions for making all of the proteins in our bodies. Now, there are actually two types of DNA-containing genes, somatic and germline. Your somatic cell genes program for your typical body cells, the cells that'll form your skin, your veins, your eyes. And germline genes will program for traits that'll be passed down to future generations. Germline genes are the reason why you might have the same color hair as your dad, or have your quote-unquote mother's eyes. Edits given to germline genes will affect reproduction, so edits given to a parent's generation will also be passed down to kids. Throughout my speech, I'll refer to these kinds of edits as germline gene editing, germline gene engineering, or just GGE for short, but they all refer to the same procedure. The way that these edits are made is through the use of something called CRISPR-Cas9, or clustered regularly interspaced short palindromic repeats associated protein 9. CRISPR-Cas9 is a unique technology that enables geneticists and medical researchers to edit parts of the genome by removing, adding, or altering sections of the DNA sequence. Currently, CRISPR-Cas9 is the simplest, most versatile, and precise method of manipulating the genome, and that's why it's causing such a buzz in the science world right now. Let us think about it this way. The genome is like an instruction manual that makes you who you are. Now, sometimes there are mistakes in the instruction manual. People get sick or are born with abnormal defects. CRISPR-Cas9 is like whiteout. Scientists can use it to erase the mistakes or write over them, so then people don't have those illnesses or defects anymore. While this sounds very beneficial, there are actually many downsides to this prospective cure-all tool. Among the concerns of the effects of editing germline genes, possibly the most obvious and direct one is that of safety. Major agencies have been considering the use of CRISPR-Cas9 for some time, but have ultimately found that there are innumerable possibilities when it comes to the editing of germline genes. Dr. Christopher Gingell, a researcher in genetics and biomedical ethics, notes that the National Institutes of Health, or NIH, point to serious and unquantifiable safety issues in justifying their negative stance toward GGE research. Now, the NIH is an agency of the Department of Health and Human Services and is the federal focal point for health research. If they reject researching something or even supporting research for safety issues, there's definitely a good reason for this. More specifically, these safety issues concern the genetically modified child. If brought to term, they could be negatively affected by error in the edit or the genome's accepting of that edited part. Dr. Gingell again points out that the most obvious safety concerns regarding GGE stem from what are called off-target mutations, or unintended changes to the genome. Off-target mutations could potentially result in the development of cancer and other pathologies. So if we knew that these edits had the ability to give an unborn child cancer or other disabilities and diseases, would it still be okay to go through with these procedures? Now, of course, any child can be negatively affected by cancer, and that's terrible. But knowingly increasing the chances of inflicting this pain on a child and their families would break the Hippocratic oath that all doctors take, promising to do no harm. Lastly, these safety concerns not only concern the individual subject that is being edited, but could also cause devastation on a drastically larger scale. We must also look at how entire nations might decide to use this technology. After considering the clinical trials already using GGE, Dr. Jennifer A. Doudna, a professor in the chemistry and the molecular and cell biology departments at the University of California, Berkeley, writes, American spy agencies seemed rattled by the experiments too. I was shocked when the next worldwide threat assessment described genome editing as one of the 6 weapons of mass destruction and proliferation that nation states might try to develop at great risk to America. The others were Russian cruise missiles, Syrian and Iraqi chemical weapons, and the nuclear programs of Iran, China, and North Korea. Many nations have differing regulatory and ethical standards compared to those of Western countries. While those that think that GGE could only bring about peace, they fail to see the dual-use nature of this technology that could bring about and possibly even be used in war. The deliberate or unintentional misuse of GGE could have far-reaching economic and national security implications, but I'll cover those later in my speech. For now, the continued research on modifying the genome, the germline genes, without first checking the safety concerns of both the individual and mass population would surely lead to a much more danger-filled and hazardous existence. Accepting implementation of GGE can also never be morally justified due to the extensive number of embryos that are killed through this process. In order to both research and use GGE, an embryo must be torn apart by scientists in order to harvest its stem cells. During my researching process, I interviewed the senior research assistant in the cardiology division at the University of Cincinnati, Mark Erickson. He mainly works in general molecular biology and has been doing this for most of his professional career. When asked about the process of GGE, Erickson explained that where the political rub occurs is with something older than the zygote, which is formed as soon as the sperm fertilizes the egg. 3 days after the egg is fertilized, the developing embryo typically has around 6 to 10 stem cells. By the 5th or 6th day, that embryo is then known, or that zygote is then known as a blastocyst, or a rapidly dividing ball of cells. This developing individual is then destroyed to use those cells for various treatments. Erickson then noted that those cells are so attractive because you can make them into pretty much anything. Again, those cells are so highly valued because they can be programmed to become any type of other cell that might be needed. But from a scientific standpoint, what makes this so morally unacceptable? Well, every fertilized human egg will become just like you and me. They are just as much a human, whether they're a zygote, a fetus, a child, a teen, or a fully grown adult. Erickson put it this way: from a genetic standpoint, as soon as you have that zygote, that fertilized egg, you have everything you need to make a human being. Every single bit of genetic instruction is in there. And that's why he draws the line. You are experimenting on and then destroying an embryo without letting it ever leave the womb and develop into a full-grown human being. Again, that cluster of cells is not just a cluster of cells, not just a sample to test on and then get rid of. That zygote is just as much a human as you and I are. You would not deliberately kill a child just to use their cells, so why are we okay with the destruction of these zygotes? So now that we know how these stem cells are harvested and what makes this approach so ethically unacceptable, I will point to the reason why we need to fight against this. Human life is intrinsically and innately valuable, and we are commanded by an almighty God to protect all human life. Hill Hawker, the holder of the Richard McCormick Endowed Chair for Theological Ethics at Loyola University Chicago, makes an interesting point here. She wrote that researchers and future parents have an obligation to respect the morally relevant status of the human embryo. But germline gene editing does not meet this obligation because it either renders the embryo morally neutral or diminishes it to the status of property or goods. There's a special sacredness in human life itself, and it is our obligation to ensure that all human life is treated with equal respect. Not only is it an obligation, but it is a command from the creator of life himself. And we can see this written all over the scriptures. For instance, Psalm 139, 13 through 16. You formed my inward parts. You knitted me together in my mother's womb. I praise you, for I am fearfully and wonderfully made. Wonderful are your works. My soul knows it very well. My frame was not hidden from you when I was being made in secret, intricately woven in the depths of the earth. Your eyes saw my unformed substance. In your book were written, every one of them, the days that were formed for me, when as yet there was none of them. Jeremiah 1, 4 through 5. Now the word of the Lord came to me, saying, before I formed you in the womb, I knew you, and before you were born, I consecrated you. I appointed you a prophet to the nations. Exodus 20:13. You shall not murder. Each of these verses shows us that all human life has value in the eyes of God, and should therefore have value in our eyes as well. But due to the mass embryonic destruction that GGE entails, this technology can never be morally justified. GGE would not only harm the individual subject that is being edited, but it would be dangerous to the social interactions that people have every day, along with the collective society itself. If implemented into common practice, it would be unreasonable to think that this technology could be distributed equally. But why is this a problem? Well, allowing some, but not all, to benefit from GGE and be able to edit the futures of their children would prove to be very harmful to society as a whole. Dr. Doudna is concerned about this subject as well. She knows that just as it's hard to know where we draw the line when it comes to editing embryos, it's difficult to see how we do it equitably. That is, in a way that improves human health across the board, not just in certain groups. Since the wealthy would be able to afford the procedure more often, and since any beneficial genetic modifications made to an embryo would be transmitted to all of that person's offspring, linkages between class and genetics would ineluctably grow from one generation to the next, no matter how small the disparity in access might be. Even in countries with comprehensive healthcare systems that allow all people, regardless of class, to benefit from GGE, there are still risks that might give rise to unseen inequalities in terms of genetics. A sort of gene gap would only widen over time. Consider for a moment the socioeconomic effect this would have on society. Those with more money would then be able to live healthier and longer lives due to their privileged sets of genes. If you think that the world is unfair now, imagine this current fiction becoming a future reality. GGE does not keep every individual in mind. It disregards the future thoughts and wills of the modified unborn babies. It disregards those who cannot afford to have their children edited, who cannot afford to make their children live healthier and longer. It disregards the entire human race, except for a select few who are lucky enough to have their genetic makeup altered. It disregards life itself. Despite this, the current idea of what GGE would be used for is for the correction of mutant genes, solely for the purpose of curing and preventing illnesses. The line, however, becomes blurry very quickly between simple cures and enhanced abilities. There's no real boundary between the two. We must accept the fact that this technology will be misused, whether it's for increasing speed, strength, intelligence, reducing age, or making some more attractive than others. This is a rapidly progressing field. And typically, with rapid progress in any technology comes the price of obsolescence. And this technology will be used on people to enhance their abilities. Therefore, if we put the two together, we can see that this technology will make people themselves obsolete after a certain point. Dr. Robert Sparrow, a professor at Monash Data Futures Institute, believes that people's responses to each other will be shaped by the dates of enhancements. So date of enhancement would become a new axis of social stratification. Imagine a world where your level of upgrade became a new way of classifying people. Does this not sound like something straight out of a video game? But it's true. Soon, date of enhancement might be part of the greeting you give to someone, right alongside your name and what you do. It could be required on resumes, IDs, government documents, legal forms. Imagine anywhere you inserted your date of birth, there's a box right next to it, labeled date of enhancement. If genetic enhancements available to parents get better and better every year, not only would this be a talking point, but it would be a way of deciding ability and fitness as well. GGE may start with good intentions such as disease prevention, but while you're at it, why not throw in an enhanced metabolism? How about give the kid perfect eyesight? How about height or muscular structure, a full head of curly red hair, or the gift of extraordinary intelligence? Surely none of those are going to hurt the kid, right? But if genetic enhancements available to parents get better and better every year, then children enhanced any 1 year would quickly become obsolete. Those with newer enhancements then would then be more relevant and able-bodied compared to those with old enhancements or no enhancement at all. the obsolete. Back in 2020, many of the leading bioethicists from around the world came together for a conference titled The CRISPR Apple on the Tree of Knowledge to discuss the morality of germline modification. One of the highlights from this conference was that people born without enhanced physical, intellectual, or creative abilities could hardly compete, so social mobility would decline, and the gulf between advantaged and disadvantaged would widen. The older someone is, or if they lack enhancement, the less likely they are to attract employers who may have been interested in employing them. The less likely they are to make it onto sports teams. The less likely they are to be successful at all. And how far would we be willing to let this go? If some genes are preferred over others, the desire to remove genes from the gene pool in conjunction with the existence of genetic enhancements would surely lead to disastrous results. Again, these leading bioethicists pointed out that disastrous consequences of germline modifications can also be imagined, such as the development of master and slave races, as genetically superior people forbade genetic enhancements to inferiors. Master and slave races. It seems far-fetched, but history says otherwise. We have already seen the horrors of attempting to cleanse the gene pool in cases such as the Holocaust. Now, imagine something similar. A totalitarian government with engineered super soldiers that'll do anything that the state tells them to do. The aftermath would be catastrophic. And if this is what we can imagine, think about all the effects of GGE that cannot be regulated. All forms of germline gene modification must be banned around the world. Who knows what some will do with this technology in a world where slavery, human organ harvesting, and black markets continue to be a problem. The societal risks of GGE far outweigh the benefits, and therefore, we cannot let this technology be implemented into common practice. Advocates of GGE, however, believe that this potential should not be wasted, that the benefits outweigh the disadvantages. Now, GGE does give doctors the ability to precisely alter, turn off, or remove the single gene that causes many diseases and disorders. In fact, the U.S. National Library of Medicine states that these procedures are being explored in research and clinical trials for a wide variety of diseases, including cystic fibrosis, hemophilia, and sickle cell disease, which are all single gene disorders. Yes, this would lead to the removal of all disease-causing genes in an embryo, so it will no longer carry that life-threatening mutation and would also not pass it on to any of its offspring. And yes, this method is simple compared to previous ones. In addition, it is easier and cheaper and more effective at removing single gene disorders and diseases. Germline gene engineering, however, is not the only option. Patients with seemingly incurable diseases can look elsewhere to similar operations but with far less risks. Let me explain. Remember how I said there was two types of DNA-containing genes? Well, there are two ways to edit the genome. Like previously mentioned, the two types were germline cells and somatic cells. I've been arguing against the use of germline cell edits, but we have not yet considered the somatic cell edits. In reality, these two methods create very similar effects. Somatic cell edits are not passed down to future generations, but they're not any less effective on the diseased patient. Somatic genome editing techniques make permanent changes to the genome, treating the cause rather than the symptoms of disease, says Dr. Laura Blackburn, the head of science for the Foundation for Genomics and Population Health. These edits are permanent. They're not just a band-aid that covers up the problem without actually fixing it. They are surgical procedures that go in and address the root cause of the problem. And many could turn to somatic cell editing for the same reason that they would turn to germline gene editing. According to author and university research professor Françoise Baylis, the potential health benefits of genome editing for patients with a serious genetic disease are considerable, and many are excited at the promise of therapeutic somatic cell genome editing. They anticipate a world in which it will be possible to treat diseases involving a single faulty gene, such as Huntington's disease, cystic fibrosis, and muscular dystrophy. They also imagine using somatic cell genome editing to treat more complex diseases with a genetic basis, including cancers, dementia, and some forms of heart disease. Somatic cell editing is not using blastocysts, and therefore they're not killing unborn babies. They also do not possess any of the dangers that I've already spoken of passing on created traits. Without the loss of life and consequences of inheritance, somatic cell editing is by far as safer and just as effective as germline gene editing. Editing the germline for disease prevention is both unthoughtful and deadly when considering the consequences, especially when there are alternative options. In conclusion, engineering germline genes must be prohibited. due to the dangerous societal and individual effects, along with immoral methods of research. Now, the last thing I want is for you to walk away thinking that this is too futuristic and that it doesn't apply to you. For those that believe that this is something that's just too far down the road and it won't affect you in your lifetime, I'd point you to the fact that at least one of these procedures has already been performed 5 years ago, and very likely many more that have just been done in secret. In addition, GGE is being heavily researched and analyzed as we speak. This is not an issue to be apathetic about. And I know that you're not genetically modified, and you may not plan on having your kids genetically modified. So why should you care? Well, there is still a reason. The number of lives lost in the lab is a considerable matter. And for me, I see this issue as that similar to abortion. I've never had a baby, but I can still have an opinion on a subject that is taking innocent lives. And the same goes for GGE. If you believe in the sanctity of life, you believe in the sanctity of all life. Lastly, I'd like to ask a question. By a show of hands, how many have heard of this procedure, specifically germline gene engineering, before my speech? Okay, so decent amount of you. But still, this is a very young issue. And the first step to ensuring that this procedure is not a danger to humanity is by spreading awareness. Tell your family, your friends. In my opinion, this is a very interesting talking point, and it may be the future of medicine. And people need to know the consequences of germline gene engineering. If you care about the lives lost in the lab, if you care about the future of our species, if you care about what it means to be human, then you should care about germline gene engineering. Thank you.